In this video, we are going to see about what are the assumptions in significance testing. Statistical tests commonly assume that. Assumption 1. The data are normally distributed. Assumption 2. The groups that are being compared have similar variance. Assumption 3. The data are independent. If your data does not meet these assumptions, you might still be able to use a nonparametric statistical test, which have fewer requirements, but also make weaker inferences. Let us discuss in details how these assumptions affects the significance test. Statistical significance helps quantify whether a result is likely due to chance or to some factor of interest. When a finding is significant, it simply means you can feel confident that's it real, not that you just got lucky or unlucky in choosing the sample. When you run an experiment, conduct a survey, take a poll, or analyze a set of data, you're taking a sample of some population of interest, not looking at every single data point that you possibly can. Consider the example of a marketing campaign. You've come up with a new concept and you want to see if it works better than your current one. You can't show it to every single target customer, of course, so you choose a sample group. When you run the results, you find that those who saw the new campaign spent $10.17 on average, more than the $8.41 those who saw the old one spent. This $1.76 might seem like a big, and perhaps important difference. But in reality you may have been unlucky, drawing a sample of people who do not represent the larger population. In fact, maybe there was no difference between the two campaigns and their influence on consumers' purchasing behaviors. This is called a sampling error, something you must contend with in any test that does not include the entire population of interest. There are two main contributors to sampling error. 1. The size of the sample. 2. The variation in the underlying population. How sample size affects the significance test. Think about flipping a coin 5 times versus flipping it 500 times. The more times you flip, the less likely you'll end up with a great majority of heads. The same is true of statistical significance. With bigger sample sizes, you're less likely to get results that reflect randomness. How variation affects the significance test. In this image above, each expresses a different possible distribution of customer purchases under campaign A. In the chart on the left, with less variation, most people spend roughly the same amount of dollars. Some people spend a few dollars more or less, but if you pick a customer at random, chances are pretty good that they'll be pretty close to the average. So it's less likely that you'll select a sample that looks vastly different from the total population, which means you can be relatively confident in your results. Compare that to the chart on the right, with more variation. Here, people vary more widely in how much they spend. The average is still the same, but quite a few people spend more or less. If you pick a customer at random, chances are higher that they are pretty far from the average. So if you select a sample from a more varied population, you can't be as confident in your results. To summarize, the important thing to understand is that the greater the variation in the underlying population, the larger the sampling error. If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.